All right, let's dive in. We're about to go on a pretty incredible journey, one that shows how a simple question can blossom into a full-blown scientific discovery. This is the five-phase roadmap that every piece of quantitative research follows, and we're going to walk through it step by step. So, have you ever actually wondered about that? How does an idea, that little spark a nurse might have in the middle of a long shift, how does that turn into hard evidence that can actually change how things are done all over the world? Well, it all happens through this really structured five-part story. Let's start right at the beginning, with that first spark of an idea. So everything kicks off here, in phase one, the conceptual phase. Now, forget about beakers and lab coats for a second. This part is all about the intellectual heavy lifting. It's where a kind of vague interest gets hammered and shaped into a sharp, focused research problem. And this scene just captures that feeling perfectly. You see a researcher totally surrounded by existing knowledge. This is the real starting line. You're sifting through what's already known, trying to find the gaps, and basically wrestling with these big ideas until you can forge them into a really clear problem statement and a hypothesis you can actually test. So, how does that actually work? Well, first, you take a broad topic you're interested in and you narrow it way, way down to one specific problem. Then, you dive into what's called a literature review, because, hey, you don't want to reinvent the wheel, right? After that, you build a framework, which is kind of like the logical map for your study. And finally, you state your hypothesis, which is really just your best, most educated guess about what you think you're going to find. Okay, now this right here is absolutely crucial. You can't just go into a study saying you're going to measure anxiety. I mean, what does that even mean? You need what's called an operational definition. It's the official rulebook for how you'll measure something. So as you can see here, the fuzzy idea of anxiety becomes something super concrete, a score over 50 on a very specific, validated test. This is what makes research precise and lets other people repeat your work. Okay, let's move on to phase two and see how this all builds. Once you have that crystal clear question, it is time to become an architect. This is the design and planning phase, and it's where you create the super detailed blueprint for your entire study. This overhead shot pretty much says it all. You're making these huge decisions about how the study will be designed and who's going to be in it. And you see that confidential stamp? That is so important. Ethics aren't something you think about later. Protecting the people in your study is woven right into the plan from day one. Now, this slide shows one of the biggest forks in the road for a researcher. Are you going to run an experiment where you actively change something to see what happens, kind of like testing a new drug against a placebo? Or are you going to do a non-experimental study where you just observe things as they happen naturally, like tracking people's diets to see how it affects their health? Both are incredibly powerful. They just answer very different kinds of questions. And the planning here is just unbelievably detailed. You've got to define exactly who you're studying, figure out the best way to pick a smaller sample that represents that whole group, and you even have to plan how you'll analyze the data before you have any. You also run a tiny pilot study. Think of it like a dress rehearsal. It helps you find and fix any problems before you sink all your time and money into the real thing. All right, the blueprint is officially approved. Welcome to phase three, the empirical phase. This is where the plan gets put into action. It is the boots on the ground part of the whole process, where you actually go out and collect the data. And this scene puts us right in the heart of it. You see a nurse, researcher, right at the patient's bedside, carefully collecting information on a tablet. Whether it's through an interview, a survey, or even taking readings from medical equipment, this is that critical moment where the abstract plan meets the real world. But just collecting the data is only the first part of this phase. All that raw information has to be meticulously checked for mistakes and then coded. Coding just means turning words or responses into numbers so a computer can make sense of it all. This careful preparation is absolutely essential for the analysis that's coming up next. Which brings us to phase four, the analytic phase. We've got our squeaky clean, organized data. Now it's time to interrogate it, to run the numbers and see if our hypothesis was right. This is where we finally start looking for the patterns and the story hidden inside all that data. And wow, this visual just perfectly illustrates that moment of transformation. You see the neat little rows of data in the software, you click a button, and suddenly, boom, that data comes to life as these dynamic graphs and charts. This is the exact moment when the numbers start talking, revealing trends and relationships you couldn't see before.
The very first step is always to just summarize everything. You use what are called descriptive statistics, things like the average, the middle value, and how spread out the numbers are, just to get a basic feel for your sample. What's typical? How much do things vary? It gives you that first bird's eye view of your results.
Okay, next up is the real heavy hitter, inferential statistics. This is where you actually test your hypothesis. So think about it this way. Your study only had a small sample of people, but you want to know if your findings apply to everybody in that larger group. Well, these are the tests that tell you the probability that your results are real and not just some random fluke. It's how you get to go from saying, this happened in our study group, to this is probably a real effect out there in the world. So you've found something. You've crunched the numbers. You've figured out what it all means. But the journey is not over. In fact, you could argue the most important part is just getting started. Welcome to Phase 5, the dissemination phase.
I mean, a discovery that's kept secret doesn't help anyone, right? As we're seeing here, the whole process ends with sharing that knowledge. Whether it's standing up and presenting at a big conference or getting your study published in a journal, the whole point is to get your findings into the hands of the people who can actually use them.
And there are a few main ways this happens. The findings can be turned into a formal journal article, you could give a presentation, it might be part of a dissertation to earn a degree, or it could even be a special report made just for the people who write the rules and policies.
And this quote just gets right to the very heart of why we do this whole, long, painstaking process. It has one ultimate goal: to create evidence that makes a real-world difference. It's all about making care better, changing policies for the good, and lighting the way for the next big discovery. And that's the whole journey, 5 distinct phases that take a simple question and turn it into knowledge that can have a huge impact. It really makes you think, doesn't it? Now that you've seen the whole roadmap, what's the one question you would want to investigate?